All right, section 1.4. The title of this section is called Subsets of Lines and Planes. Basically, it just means we're going to talk more about lines, more about planes. Okay, just add some stuff in there. So the first thing is a definition. All right, and the definition is something that really I had not heard until I taught out of this book last year. This is the first time I've heard this. They call it a half line. Okay, and it says, so again, the title of this lesson is Subsets of Lines. So it says a half line is a subset of a line containing all the points on a given side of a point on that line. What in the world does that mean? So if you had a line, let's draw a line, and we know a line has these arrows on the end of it. All right, let's read the definition again. It says it consists of all the points on a given side of a point on a line. So if I have a point right here, we'll just call it point A. And I'll tell you what, I'm going to call this B down here. It doesn't have to go in order. And I'll call this C right here. That's good enough. And if we talked about a half line, it's all the points on a given side of a particular point. So if I say point A, that's the particular point. All the points to the right would be considered half of a line. All the points to the left would be considered half of a line. To tell you the truth, I don't know what the difference between that and array is. We are going to talk about array. Oh, I know what it is. Array is everything including the point. So really, everything past point A would be a half line. Everything to the left of A, not including A, but everything to the left of A would be a half line, right? When I was in college or in high school, and when I've taught out of several different geometry books, I've never heard anybody talk about a half line. So I'm not going to worry too much about that half line, all right? Let's move on to something that we're really going to use. And the next one is really important. And you're going to use this a lot. So a half line, I don't ever recall doing a whole lot of stuff with that. But array is definitely something that we use quite a bit, okay? So it says, I'll give you the definition. It's on page 19. It says array is the union of a half line and its origin. So basically means if you start at A and go either to the right, start at A and go to the left, that's considered array. A half line just does not include A, all right? Does that make sense? So we just don't include the point. So it's kind of the same, but a little bit different. So let's draw array. We will use this quite a bit. You've heard of angles, haven't you? All right, so we'll use the word ray when we talk about some angles. I don't know if we're talking about angles in this lesson or not. Yeah, we are. This lesson does talk about an angle. Figured it would since we talked about array. So array starts at a point and it goes in just one direction. See the difference between a line and array? Array goes in forever in both directions. Array starts at one particular point and just goes in one direction. So that could be array. You could have array like this. Okay, that would be array, right? If it starts at a point right here, you could have array going in this direction, like this. Okay, if it starts at a point. So these are all rays. Everybody got it? Starts at a point and it just goes forever, just in one direction, and that's it. So let's put some points in here. Let's just call this A, we'll call this B, and we'll call this C. And again, it doesn't always have to go from left to right. It could be slanted. It could go from right to left. It could go up and down, all right? Or it could go up, or it could go down. So it can go all these different angles. But right now, we're just doing this ray right here. So first of all, when we show a line, or when we show or we write a line, what do we write? So if it's line AB, what would we write? Just AB? We could put the word line in front of it, but what's a better way to do it? What's our symbol? Yeah, just the little arrow on the top, just like that. Now this is just this is just a regular line. I'm just going back to regular line because I want to show you the similarities between a line and array. So don't worry about half line anymore. Okay, that's, I don't know, it's not nonsense, but it's something we don't really talk about much. But we do talk about array a whole lot. So array looks like this. So what we do now, if this was a line, forget half line. we could write it line AB, or we could write it what?
Or AC.
Well, let's just use the A and the B. I could go BA, couldn't I? Everybody see that? So I could call that either way. Array is a little different, though. Array, it definitely matters which one is first. Okay, it absolutely matters. What do you think? Like, looking at this array right here, which one of these do you think is going to be first? The A, exactly, because that's where it starts, right? Start at the beginning, starts right there, so you start at A, right? Now, here's the thing that's a little bit different, or kind of the same, I guess. If I wanted to call this Ray, I start at A, but the second point that you put for Ray is any point on that Ray, right? So I could call this what? Ray A, B, or I could call it what? Ray AC. Now, could I call it Ray BA? No, why not? Doesn't start at B, does it? It starts at A. So the A has to be first. So lines, you could go back and forth like this. But array, the beginning letter, the first letter, absolutely matters. All right, so wherever it starts, right here at A, that's going to be our first letter. But I could call it Ray AB, right? And here's the symbol for array. It's just an arrow in one direction. Now, we always put it to the right. When we do our arrow always goes to the right. Whether or not our ray is slanted, whether it goes to the left, or whether it goes up or down, it doesn't matter. We write our A, or we write our ray, I should say, with the arrow always going to the right. Okay? Remember, this is not, you can't say or ray BA, because it's not the same. This doesn't start. This picture right here does not start at B. It starts at A. Okay? Now, you could do this. You could write Ray BC, but is Ray BC the same as Ray AB? No. Where does Ray BC start? At B, exactly. So none of this part right here, from A to B, none of that would be included. If I said Ray BC, I'm not talking about any of this right here. It would start at B and it would go through C. Make sense? Okay, so that's what array is. And those are really, really important. So like if this was X and this was Y right there, what's the name of this ray? Ray XY. So ray XY. Now, even though this is slanted up, it's angled up like this, we still write our ray symbol just like that. It always is to the right. Everybody got that? Okay, good. So that's something we're going to be using a lot. I mean, most of the year we'll be talking about stuff like that. Let's do this. Let's talk about things that are called opposite rays. So there's it. Boom, boom. Put right there. What do I want to put? SP and R. Okay, so S, P, and R. Now you got a couple rays that you could write, couldn't you? You could. Well, you don't know any points after R, so you can't really start at. Well, you could start at R. If I want to write a ray that starts at R in this situation, how would I write it? I wouldn't go from R this way because I don't know any points over here, but I do know some points over here. So I can start at R and go which direction? Right, to the left. So I could call this ray what? RP, or I could call that ray RS, right? Because it keeps on going, right? It doesn't stop at P.
Why could it be S?
Well, it could. I'm just saying if you started at R. Okay, that's what I'm doing right now. So if I start at R, okay, the two rays that I could name would be ray RP and ray RS. And they would actually be the exact same ray. They're not really two different rays because, again, it keeps on going forever in that one direction. Okay, you see that? So ray RP is the exact same ray as ray RS. And you're like, well, RS, I mean, it just keeps on going, right? So R to P, it doesn't stop here. It just keeps on going. So RS is the exact same ray. Now, what if I wanted to start at S? Now we're going to do this, Connor. We start at S, and what could I call that ray? SP, or I could call it ray SR. Okay, you with me on that? But what they're talking right now is they are talking about opposite rays. And this word does pop up every once in a while, so I think it's important. So opposite, oops, it's supposed to be a T, it's kind of weird. That's opposite rays, right? So what's an opposite ray? An opposite ray is a ray that starts at the same point but goes in two different directions, okay? Now, they're two different rays. They're not the same ray, but they do go in different directions. So the opposite rays, they would both start at P. So give me a ray that starts at P in this situation. P what? PR, okay? So ray PR is an opposite ray. I'll just put opposite. Opposite ray to what? Well, again, it has to start at the same spot, okay? PS, exactly. Okay, so we would go ray PS. Now, even though ray PS is going to the left, notice our little symbol, it still goes to the right. Okay, so the symbol doesn't really give you any indication which direction it's going. That's just the symbol all the time for a ray. So these would be opposite rays. So PR, all right, let's do this in a different color. So make it a little thicker. So ray PR and ray, let's do that different color, and ray PS, okay, they are opposite rays. They're not the same ray, they're opposite rays because they have the same starting point, but they go in complete opposite directions. You with me on that? All right, now, so you're not confused. Oops, don't want to do that. What do I want to do? This. Okay. So what about this and like that? Now here's two rays, right? But are they opposite rays? They do have the same starting point right here. So they're not opposite rays because they don't go in complete opposite directions. So really, opposite rays kind of form a what? A line. They form a line, don't they? This doesn't form a line, does it? Because it's not straight. You got that little bend in there, little angle. And this is an angle, and that kind of leads us up to what we're going to talk about in just a minute. Okay? So these are not opposite rays. These are opposite rays. Okay? So we're just kind of doing definitions right now and again, learning how to label things and stuff like that. There is a definition about between. I think I'm going to skip that. Opposite rays, a segment. Okay, this is a good one to do. So if we talk about a line segment, let's write that down. So line segment. It's not just a line, but it's a line segment, which means it actually starts and stops. It has a starting place and it has a stopping place. All right, so it doesn't go on forever. It doesn't go on infinitely. It starts and it stops. Okay, so if I wanted to call this D and E, right, this would be considered a line segment. So we need to figure out how we're going to name it. What do you think? How do you think we're going to name this? Remember, it just starts here and it stops here. Or you could say it starts here at E and stops here at D. How would I name that line segment? That's it. Put DE and put just a little line with no arrows over top of it. That means a line segment. It doesn't keep on going forever. That's why it doesn't have any arrows on there. Okay, it starts and it stops. Okay? Or, what else do you think I could call this? You don't have to start with the left-hand side. Simone, did you say something? ED, right. Line segment, let's call it line segment ED. So either one of these would be perfectly fine. Wouldn't make any difference, okay? Now let me ask you this. What if I put F right there? Is line segment DF and line segment DE the same line segment? If it was a line, yeah, they would be exactly the same, wouldn't they? I could call it DF or I could call it DE. It'd be the exact same line. But since it has a starting and a stopping spot, is DF exactly the same as DE? No, it's not, because DE's got all this more, doesn't it, than what DF does. DF starts and stops here, so it's shorter, isn't it, than between here and here. The one word I was going to skip is the between. Between just means, they give some fancy definition of between, but it basically means there's a point to the left of it, there's a point to the right of it. All right, that means F is between D and E. Okay, I'm not gonna. They do this whole subset thing and is an element of, and I don't know. To me, I just don't think that's super important right now for what we're doing. Okay, enough of that. Let's move on. We're getting somewhere here. No, don't want to talk about that. Don't want to talk about that. Don't want to talk about that. Let's get to this. We kind of alluded to it right here, so now we're actually formally going to get to it. So let me draw something for you. Something like this. Something like that. And what I'm going to do is I'm going to put arrows on the end of these. So basically we have two what? Two rays, right. But they connect at one common point, don't they? You see it? They intersect each other, if you want to call it that. Okay? That right there, the common point that they have in common right there, we call that the vertex. Okay, so that point right there is called the vertex. And let's name it. Let's call that B. Let's call this A. And let's call this C down here. What do you think the whole thing is called? It's an angle. It's an angle. All right? And let's talk about how to name it. So the whole thing is an angle. So basically an angle are two rays with a common endpoint. So an endpoint is the point that's on the end. All right? I don't think I said that earlier, and I should have when I talked about a ray. Okay? See right there? What's the endpoint of ray AB? What would I say the endpoint of ray AB is? Where does it start? It starts at A, right? So that point, okay, that point where it starts, even though we call it endpoint, all right, it's basically where it starts, okay? So that would be the endpoint. What about this one, XY? What's the endpoint to ray XY right here? It's X. Everybody see that? So now let's come back up to this. What's the endpoint of ray BA? It's B. What's the endpoint of ray BC? It's B. That's the common endpoint. Everybody got that? So that common endpoint we call the vertex. The whole thing is called an angle. So it's two rays with a common endpoint. This is how we name a ray, or we label it, I should say. This is how we label, not a ray, but an angle. So we use this little symbol right there. Kind of like an L, but it's kind of slanted a little bit, all right? So we use that no matter which direction the angle is facing. We always use this for our angle symbol, all right? And what we do to name an angle, we're going to use, well, you could just use one point. What do you think would be the one point that we would use if we were to just use one point on that angle right there? B, right, because that's the common one, all right? So if you just said angle B, that would be perfectly fine. In this situation, I'm going to show you another situation that won't be fine, all right? But in this situation where there's only one angle coming out of that vertex, then you could just name it by that vertex. You could just say it's angle B. Or you could use 3 points. But the B has got to be in the middle. All right, the vertex has to be in the middle. So there's a couple ways you can name this, 2 ways you can name this with 3 points, but the B or the vertex always has to be in the middle. So how do you think we're going to call this? We're going to call it angle what? ABC, good. ABC, or you could also call it CBA. Well, what's super important about this? That the B is where? In the middle. It's got to be the second one, okay? It's got to be the middle one. Everybody with me? You cannot call it BAC. BAC is not an angle in this situation right here. Okay, the endpoint has got to be in the middle. All right, I've said that enough, haven't I? Yeah. All right, let's talk about this, and I think, yeah, we're pretty close to done. And we've got like 4 more minutes left, so I'm good here. So let's say we put a point. Let's say we put a point right there. Where in reference to the angle is that point? Do you think it's inside? Do you think it's outside? Do you think it's on it? Do you think it's somewhere else or some other word? Where do you think that point is in reference to that angle? Do you think it's on it? Do you think it's in it? Do you think it's outside it? What do you think? On it? Well, when we say on it, it's actually got to be on one of the rays. So point A is on the angle. Okay, point B is on the angle. Point C is on the angle. So now what'd you say? It's in, right, it's inside. So we say this is inside the angle. Or we use a little bit of a fancier word. We say it's in the interior of the angle, right? Interior means inside it. So any point that lies anywhere in this area right here, inside the angle, that's called an interior point. And we're going to be talking about that, okay? There's going to be things later on. We talk about the exterior point, interior points, and all that. Well, we gave it away. So what do we call that point outside the angle? Exterior, good. So we call that an exterior point. And again, if it's right on the ray itself, we just say it's on the angle, all right? So point A is on it, point C is on it, point B is on it. This point right here, whatever it is, D, that's inside the angle, or it's in the interior of the angle. And if this is E, we say that's the exterior of the angle, or it's outside the angle. We good? All right, let's do another thing. I said before, remember I said that it was okay on that one just to use one letter. We could just call it angle B. Well, here's a situation you just can't call it angle B. You're probably wondering what that is. Well, I'm going to show you. Let's make that go like that. Okay? Now look at this. We got more than one angle, don't we? In fact, how many angles do we have? We got 3. We got, what? I heard 2. Which one? You want to fight it out? Okay, so let's do this. So Zion said you got angle ABC, so that's one angle, right? I'll just stick a 1 in there. What's the other one? Give me another one. CBD, that's a second angle. Where's the third one? ABD. That's right, the whole entire thing, right? ABD. So that whole entire one right there would be angle 3. So you do have 3 angles here. Now, the problem is I can't just say angle B, because how do you know which angle you're talking about? If I just said angle B, which one's angle B? Is it the whole thing? Some people might say, oh yeah, it's just the whole thing. But this also has B as a vertex, and this one right here has B as a vertex, okay? So you can't just say angle B in this situation. Does everybody see that? That's important. That's something that a lot of students don't really get for a while. So if I wanted to call this little skinnier angle right here, if I wanted to call that something, what would I call it? Angle ABC. If I wanted to call this angle down here at the bottom, this one right here, I'd call that one what? Angle CBD. And then if I wanted to call the whole angle something, then what would I call that one? Angle ABD. Make sense? Yeah. So that's pretty important stuff because you're going to be doing that a lot. Now, sometimes they also do this. Just give me a sec. Sometimes they also do this. You know how I put the 1, 2, and 3 there? Sometimes they'll put a 1 right there. So instead of calling it ABC, you could just call it angle 1, right? Sometimes they'll put a 2 right there. So instead of calling this BCD, you could just say angle 2, right? You're going to see some of that on your homework. All right. Somebody tell me what the homework is. You got the paper in front of you? It's section 1-4.
Page 21, 22,
21, 22, 1 through 12.
21 through 12, 1 through 12,
Yeah.
and 30 to 42.
1 through 12, and then it jumps to 30.
Yeah.
30 to 42. And don't do what?
2 and 38.
2 and 38. Okay. It says omit. So what does omit mean? Don't do it. You leave it out. Okay. So there you go. So you don't have to do 13 to 29, right? Is that correct? That's everything? All right. Very good. Okay. Thanks, guys.